Welcome to lesson 2.3, day 2, solving multi-step equations. Today's objectives, we're going to solve equations involving consecutive integers, and we're going to solve equations with fraction using lowest common denominators. First, let's look at what are consecutive. So two consecutive numbers are numbers that follow one another, like n and then n plus 1. So we have examples are 1, 2, 3, 4, 5, it keeps going. Then we have 24, 25, 26, 27, 28, keeps going. And negative 3, negative 2, negative 1, 0, 1, 2, 3, 4, 5, keeps going. When we're looking at consecutive even integers, we're looking for just the even numbers. So here we have 4, 6, 8, and how we represent that algebraically is we'd have n plus 2. So if we started with 4, we'd have the next number is 4 plus 2, which is 6, and then 6 plus 2, which is 8. That's how we have that n plus 2 there. Consecutive odd integers is the same idea, except for now we're looking at just the odd numbers, so 3, 5, 7, and again we look at that n plus 2. If we start with 3 and add 2, we get 5. We have 5 plus 2, we get 7. We're going to show you how to set these up. These are quite common. So what is the next consecutive integer? In this one we have 6, 7, 8, and then it has an x as a placeholder. So our next number would be 9, and then it would go 10, and it would keep going. For the next one, we have negative 15, negative 14, negative 13. The next number is negative 12. For number 3, you'll notice we're jumping by 2s. So we have 22, 24, 26, 28. The next number is 30, and then it goes 32, ... There's my ellipse. And then the last one, we have 37, 39. The next number is 41, and then it goes 43, and it would keep going. Number 3 is even integers, and number 4 is our odd integers. So here we have find 3 consecutive odd integers with a sum of 57. So we want to find 3 numbers that are consecutively odd, and we want to have a sum of 57. So our first integer, we're going to call n. And then our second integer, we're going to jump by 2s, so n plus 2. And then our third integer, this is where it can get tricky, is basically n plus 2 or n plus 4. So now we can write our equation. So we have our first integer plus our second integer plus our third integer has to add up to 57. And there is my equation. You don't need to put the parentheses in here, but I'm showing you that we're taking the first integer and then the second integer and then the third integer and adding them up. When you combine all these, you get 3n plus 6 is 57. We subtract 6. Now we're just solving our equations like we've been doing. Divide by 3, and we find that n is 17. So my first integer is 17, and then we have 17 plus 2, which is 19, and then we have 17 plus 4, which is 21. These are my 3 consecutive integers. 17, 19, and 21. So here's a real-life example. It says 3 of my siblings' ages are 3 consecutive even integers. The sum of their ages is 66. What are their ages? Again, we're looking at consecutive evens. So we are going to say our first person is n, the next person is n plus 2, and the third person is n plus 2 or n plus 4. And we're going to set it up the same way. N plus 2 plus n plus 4, those are my 3 siblings, equals 66. When you add them all together, you get 3n plus 6 is 66. And we solve, and we get 3n equals 60. Divide all by 3 on both sides, and we get n is 20. So my ages are 20, 20 plus 2, which is 22, 20 plus 4, which is 24. And these are their ages, 20, 22, and 24. Now we're going to move on to solving equations that have fractions in them. And there are 2 methods on how to do this. I'm going to show you both, and then you can pick which one you want to use. So our first example we have is we want to find the common denominator. And so what we're going to do is try to combine like terms and use common denominators to combine them. So the first thing I'm going to do is get my variable sorted by itself, get my 5/6 over by my 1/2, which is a like term. So I'm going to subtract 5 6 from both sides. And now I have 1/3 r equals 1/2 minus 5/6. I want to combine these two, so I need to get a common denominator. And the common denominator between 6 and 2 is 6. To make 1/2 to be something over 6, we multiply top and bottom by 3, numerator and denominator, and we get 3/6 minus 5/6. And we have 1/3 r equals -2/6. And to make this easy on myself, I'm just going to simplify it right away. So now we have 1/3 r equals -1/3. We need to get r by itself. To do that, we multiply by the reciprocal of 1/3, which is 3/1. And when you do this, you're multiplying the reciprocal, we get r, because these cancel out. And these are going to cancel out, leaving -1/1, which is -1. There is my solution. But now I need to check it. I have 5/6 plus 1/3 times -1 equals 1/2. I have 5/6 minus 1/3 equals 1/2. To keep going on the left side, I am going to get a common denominator between 5/6 and -1/3. And when I do that, I have to multiply numerator and denominator by 2. And I get minus 2/6 equals 1/2. When I subtract this, 5 minus 2 is 3. 3/6 equals 1/2. And we simplify, we get 1/2 equals 1/2, which is true. So I have a solution, and I have my check. And yes, you will have to check stuff that has fractions in it. We have another method we can use. This method is called the lowest common denominator method, or the LCD method. And I think for a lot of you, you will probably prefer this method. The reason is you get rid of all your fractions. To do this method, we look at every fraction we have in the problem. In this we have 5/6, 1/3, 1/2. And we look for the lowest common denominator between 6, 3, and 2. And our LCD in this case is 6. So we're going to take everything on both sides and multiply by 6. I'm going to show you all the steps. Then we'll show you what I will accept for work. So we have 30/6 plus 6/3 r equals 6/2. Simplify all your fractions. 30/6 is 5. 6/3 is 2. And this equals 3. So if you understand how this works, you can go right from this step right to here. I do not need to see the middle step if you know what you're doing. Otherwise, write it all out, distribute the 6 in, and write it out, and then simplify your fractions. But if you can go right to the 5 plus 2r equals 3, I am perfectly fine with that. Just show us how you're multiplying both sides by 6. Okay? And now we solve it like we've been solving equations. We move the 5 over first. We get -5 on both sides. We get 2r equals -2. And then we divide by 2. And we get r is -1. Just like the last slide. We have the same exact solution because it's the same exact equation. Except for this one, we're using the LCD method. And when you use the LCD method, if you do it properly, all of your fractions go away, which is very nice. Since we already did the check on the last slide, I am not going to do the check on this slide. We're going to get the same thing. This does work. That is all for lesson 2.3, day 2. Today we looked at consecutive integer problems, which you will have quite a few on your homework today. We also looked at 2 different methods on solving equations that have fractions in them. We can get common denominators, combine like terms, and go from there. Or we can do what we call the LCD method and multiply the entire equation by the lowest common denominator, which will get rid of all of our fractions. Make sure you show your work. Make sure you check the answers on the problems shown. And thank you for watching, and have a nice day.